All right, this video is going to cover how to draw Lewis structures. So this is really the meat of this chapter. We've gone over Lewis theory that allows us to predict the distribution of valence electrons, and this is going to allow us to understand bonding and predict shape and somewhat allow us to predict other properties. So here are my rules for writing Lewis structures. Step 1, write the correct skeletal structure. The way you do that is by making sure your hydrogen atoms are on the ends. More electronegative atoms, so halogens, oxygens, tend to be in terminal positions. Less electronegative tend to be more in the middle, except for hydrogen, which, as previously mentioned, goes on the ends. As you practice writing more of these, you'll kind of get the feel for how the skeletal structures work. Then you'll want to calculate the total number of valence electrons. Then distribute those electrons, giving as many octets as possible, with the exception of hydrogen gets a duet. And then you'll want to check your total number of electrons, make sure all the atoms have an octet. If they don't, you can use double or triple bonds to make sure that you have the correct number of valence electrons in your molecule and that all of the atoms have the octet. So let's talk about some common bonding patterns. Carbon generally forms 4 bonds and does not have any lone pairs. If your structure has lone pairs on a carbon, in this class it is wrong. Only form bonds with carbon. Nitrogen tends to form 3 bonds and 1 lone pair. Oxygen tends to form 2 bonds and 2 lone pairs. Hydrogen and halogens form 1 bond. Beryllium tends to form 2 bonds. Boron forms 3 bonds. Now, as you move on in chemistry, Lewis structures tend to be drawn with just the bonds as a line and have the lone pairs left off. It's assumed as you go on that you can figure out where the lone pairs are. And if there's a deviation from these bonding patterns, it might result in formal charges, which we'll get into in the next video, and then how to evaluate a structure based on formal charges. So let's work through an example, and then I'll have some practice for you. Okay, so writing the Lewis structure of a molecule, in this case, nitric acid. So, step 1, write the skeletal structure. The hydrogen is always terminal, and something to know, in an oxyacid, the hydrogen is attached to an oxygen. So I can write my hydrogen, it's attached to an oxygen. My nitrogen is going to be kind of in the middle, and then I have 2 more oxygens around it. So oxygen is the most electronegative, it goes towards the outside, then my hydrogen is attached to an oxygen. Now I need to count how many valence electrons I have. So my hydrogen comes with 1, my oxygens each come with 6, and I have 3 of those, and then my nitrogen comes with 5. So I have a total for this molecule of 24 electrons to account for. If this was a charged structure, I would want to either add an electron for every negative charge or subtract 1 for every positive charge. Now, step 3 is on my next slide, but since my drawing is here, I'm just going to keep drawing on this one. If you're following along in the slides, the text is on the next one. I want to attach all of my atoms just with a single bond. So now my bonds, I'm going to change my color, account for 1, 2, 3, 4, 5, 6, 7, 8 in bonds. And then I can fill in my lone pairs, making sure all of my atoms have an octet. So this oxygen here needs 4 electrons in lone pairs. Now it has those 4 plus 4 in the bond, so it has its octet. My nitrogen here has 6 electrons around it right now, so it needs 2 in a lone pair. And my other oxygens, I can fill in my 6 electrons there from lone pairs. Then I can add up how many lone pair electrons I added. I added, again in red, 18 lone pair electrons. So then I can add up 8 plus 18 gets me 26 electrons, which is 2 more than I have. The way I can fix that is by erasing my lone pair from my nitrogen, erase a lone pair from one of my oxygens, and draw in a double bond instead. Now, if I recount, I have, I'm going to have now 10 electrons in bonds, and now I have 14 in lone pairs, which now gets me my desired 24 electrons. So we can flip through there, count our electrons, and we are all set. All right, things to watch out for when you're working through Lewis structures. Remember that Lewis theory predicts that atoms will be most stable with the octet. It does not require that atoms have the same number of lone pair electrons that they had before bonding. So in the nitric acid example we just looked at, nitrogen ends up with no lone pairs, and that is the correct structure rather than the structure that did have a lone pair on nitrogen. There are some atoms that violate the octet rule that you should watch out for. Beryllium and boron are 2 of them, and then some have expanded octets once you get to the 3rd period and below. Okay, here is my big practice problem for this section. So draw Lewis structures of the following. I would recommend pause the video and work through these structures on your own, then come back for my explanation if you need it. So carbon dioxide, we're going to have the carbon is in the middle with 2 oxygens next to it. Our total number of electrons is going to be 4 from my carbon plus 2 times 6 from my oxygens, gets me a total of 16 electrons I have to account for. So if I draw single bonds, I could either fill in my lone pairs and find out that I have too many, or I could remember that carbon doesn't like lone pairs. And so in order for carbon to get an octet, it needs to form 4 bonds. So if I draw in double bonds for my carbon, then I don't have to put in lone pairs there. Then I can fill in my lone pairs on my oxygens and count everything up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, SeOF2. I'm going to put my selenium, which is my least electronegative atom, in the middle. Then I'm going to put an oxygen and 2 fluorines around it. Then I have to count up my electrons. Selenium is in group 6, so 6 for there, 6 for my oxygen, 2 times 7 for my fluorines gets me a total of 26 electrons that I have to account for. So here I'm going to start with single bonds for everything. Then I see, let's just fill in our lone pairs and check how many electrons we end up with. And then my selenium needs a lone pair. Okay, now let's count all of those up. So I have 6 in my bonds, and then I have 20 in my lone pairs, which gets me a total of 26. So there's my structure of that. NO2 minus, let me scroll down just a little bit. My nitrogen is going to be in the middle with 2 oxygens. Then I have 5 plus 6 times 2 is 12 plus 1 from my negative. That gets me a total of 18 electrons that I have to account for. So let's start off with single bonds there and then fill in my lone pairs. So now I have 16 from my lone pairs and 4, that gets me 20, which means I have too many. So I'm going to erase one of my lone pairs on my nitrogen, erase a lone pair on an oxygen, and put in a double bond. So now I have 12 plus 6, getting me my desired 18 electrons. And then for something with a negative charge, we tend to put brackets around it and write the negative sign. Moving up to the next column, H3PO4. This is phosphoric acid. So for oxy acids, we put the least electronegative one in the middle, and then we can surround it by oxygens, and then any hydrogens we have are attached to our oxygens. So I'm going to draw in my bonds there. I'm going to draw in single bonds here, and let's fill in our lone pairs. This one has the extra one because it doesn't have the bond to the hydrogen. Now I forgot to count how many electrons I need. So I have 3 from my hydrogen, 5 from my phosphorus, 4 times 6 for my oxygens, getting me a total of 32 electrons. And now I have 1, 2, 3, 4, 5, 6, 7 bonds, so that's 14 plus my 18 lone pairs gets me my desired 32 electrons. So that one's all set. SO3 2 minus. I'm going to put my sulfur in the middle, surround it with my 3 oxygens. Now total, each oxygen comes with 6, so does my sulfur, plus 2 from my 2 minus here. So that gets me a total of 26 electrons. So I'm going to fill in my bonds here, and then my lone pairs, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I have 20 in lone pairs plus my 6 in bonds. Gets me a total of 26. So I'm all set there. Again, brackets with the 2 minus. And then finally P2H2. So I'm going to have my 2 phosphoruses attached to each other, and then each one of those will have 2 hydrogens, and then fill in my lone pairs, and my total electron should be 4 plus my phosphorus has 5, so 4 plus 10 gets me 14 electrons total. And I have 1, 2, 3, 4, 5, so 10 in bonds plus 4 in lone pairs gets me 14. So that one is all set. So there are all of those Lewis structures, I would recommend working through the homework to get more practice with Lewis structures. If you need extra practice, there are plenty in the back of the chapter that the answers are in the back for even more practice on this topic.